Hello everyone. In the previous video we have seen binary search algorithm in which a single middle was dividing the entire array into two parts and then searching for the element. Now in this video we will be seeing ternary search algorithm in which it includes two different middles. So let's have a look at it at a glance. Ternary search also works on sorted data. So let's have a look at the algorithm. So the first step is to define the first element's position as low and the last element's position as high. Next step is to define two different middles. Name the first middle as middle 1 and the second middle as middle 2. For finding both the middle elements' position, we have a formula. So for finding the middle one, we have the formula low plus high minus low divided by 3. This formula will give the position of the middle element which lies in the first half of the array. Similarly, we have a formula for finding the middle element of the second half of the array, and the formula is high minus low divided by 3. Once you get both the middle elements' position, you need to compare both the middles with the element to be searched. Now after comparing, there will be 4 different possibilities. The first possibility is that the element to be searched is equal to any of the middle element. Then in that case, just return the position and stop. In the second case, if the element to be searched is lesser than the element which is present on the middle one position, that means the element lie to the left of the middle one position. In that case, make middle one minus 1 as high and repeat the step. In the second case, the element to be searched is greater than the element which is present on the middle 2 position. That means the element is lying on the right hand side of the middle 2 position. In that case, you need to make low as middle 2 plus 1 and repeat the step. And in the last possibility, the element to be searched lies between the middle 1 and middle 2. Then in that case, make middle 1 plus 1 as low and middle 2 minus 1 as high and repeat the step. If the element is present inside the array, you will find it until the position high becomes less than 1. This is how ternary search algorithm works. Now let's see the advantages. First advantage is that it is more efficient than binary search. Since two different middle working simultaneously, therefore there are less number of comparisons in ternary search than binary search. Because of this, the time complexity reduces to O of log n to the base 3. Now let's see the disadvantages. First is that it needs the sorted data only. It will not work on an unsorted data. It is bit complex to implement. Now let's see how ternary search works. So let's take an example of the following array. The array contains 5 elements starting from index 0 to index 4. Let's say we need to search for the element 54 which is present on index 2 with the help of ternary search. So for ternary search to work, we need to see whether the array is sorted. So here the array is already sorted. So we can proceed with the algorithm. First step is to define the low and high, which is nothing but the first position and the last position of the array. Next we need to compute two different middle. So for middle 1, the formula is low plus high minus low by 3, which is 0 plus 4 minus 0 by 3, which is nothing but 4 by 3. Now the actual value of 4 by 3 is 1.33, but we will take the floor value. So hence middle 1 will be 1. And similarly middle 2 will be 3. Now once we have got the middles, we need to compare the element to be searched with the element which is present on any one of the middle. So in our case, the element to be searched is 54 and middle 1 and middle 2 are 20 and 100 respectively. So we can clearly see that neither 54 is equal to 20 nor it is equal to 100. But we can get to know that 54 is greater than 20 and lesser than 100. That means it lies between both the middle. So now make low as middle 1 plus 1 and high as middle 2 minus 1. And repeat the same procedure with new low and high. Middle 1 plus 1 means 1 plus 1 which is 2 and middle 2 minus 1 means 3 minus 1 which is nothing but 2. Therefore, our low and high both are at position 2. Now again compute both the middles with the new low and high values. So middle 1 will be 2 plus 2 minus 2 divided by 3, which is nothing but 2, and middle 2 will be 2 minus 2 minus 2 divided by 3, which is nothing but 2. Therefore, we have got both the middles at index 2. So now the element which is present on index 2 is nothing but 54. Now check whether the element to be searched, which is 54, is equal to the element which is present on any one of the middles. So yes, 54 is exactly equal to 54. Therefore, we have found our element at index 2. So within 2 iterations only we have found our element. This is how ternary search algorithm works. In the upcoming video, we will be looking into implementation of ternary search from scratch. For more such videos, like, share and subscribe to my channel. Thank you.